Hi, this is a question which was asked in IIT JAM 2021 paper. And this is a question that is actually from the point of view of econometrics. It's from econometrics. We have already done quite a few theorems related to unbiasedness and related to what is the meaning of minimum variance, what are the blue properties, all of that we have already done. So what I'm going to do is I'm going to go ahead and use some of those properties also, and I'm going to go through a bit long process to kind of solve this problem. Okay, so I'm going to go through a lengthy process, but an easy but lengthy process, rather than going through a small but difficult process. Also, what I'm going to do is I'm going to go ahead and post a theorem on this. I'll prove this as to which are the best weights which when used will give you the minimum variance. But for now, I'm not going to go ahead and prove that theorem. And in fact, I'm just going to go ahead and I'm going to pick up on the lengthy way and I'm going to solve this question. Okay. So just try and see this. It says that alpha 1 and alpha 2 are two independent unbiased estimators. Because alpha 1 is an unbiased estimator, I know that the expected value of alpha 1 is alpha. It's an unbiased estimator of alpha. So I know that, the expected value of alpha 1 is alpha. I also know that the expected value of alpha 2 is alpha. It's given to me. These are the independent unbiased estimator. Also, what is given to me is that the standard error is sigma 1 and sigma 2. So if I find the variance of alpha 1, that is sigma square 1. If I find the variance of alpha 2, that is sigma square 2. Also, what is given to me is that they are independent unbiased estimator. Because they're independent, the covariance between alpha 1 and alpha 2, that is 0. That's the property of being independent, right? So the covariance between alpha 1 and alpha 2, that is 0. Now, I will go ahead and use this property. So I'm telling you, if the covariance between x and y is 0, what happens if I tell you, if I ask you what is the covariance between ax comma by, then you can go ahead and say that, the covariance of ax by, I've already proved this in the statistics class, is nothing but a into b into covariance of xy. And how do I know that? It's pretty simple. This can be written as the expected value of ax minus the mean of ax, by minus the mean of by. So, this is expected value of ax minus ax bar, by minus by bar, because the mean of the constant is the constant. So, this is nothing but a expected value of x minus x bar into b. B also comes out. I can directly write here. Into b y minus y bar. I can bring b also out of my expectation. This is ab, expectation of x minus x bar into y minus y bar. And if I solve this further, this is nothing but AB, covariance of XY. And I know that the covariance of XY, that is 0. Because this is what is given to me. So if the covariance of XY is 0, then the covariance of AX, BY is also 0. This is important. Another thing which is important for you to understand is that what is the variance of xy? What is the variance of x plus y? The variance of x plus y is given as variance of x plus variance of y plus 2 covariance xy. But if it is given to you that x and y are independent, then the covariance of x and y is 0. So we have the variance of x and y as, the variance of x plus y as the variance of x plus the variance of y. Similarly, if I ask you what is the variance of ax plus by, well, it is nothing but a square variance of x plus b square variance of y plus 2ab covariance of xy. But if x and y are independent, then the covariance of x and y is 0. So the variance of ax plus by is a square variance of x plus b square variance of y. All of this is important, okay? Okay, then let's go to the question now. Now the question has given us 4 options and we are supposed to go ahead and find out what would be the right choice as to what of these following will have the minimum variance. So let's just try and see which will have the minimum variance.